In machining, threading is the longest part of your cycle. But Brad here at Resolute Precision Manufacturing has completely changed that for this job shop. Brad, we're here today in Angola, Indiana, and I want to know how did you make this happen?
So I was introduced to Vargas about 2 years ago from my local distributor, and they were bragging about the new technology that they introduced from the Mach TT product line. It has been an absolute game changer from our chuckers to our Swisses. It has reduced our cycle time substantially. Our average threading cycle can be anywhere between 20 to 30 seconds per part. With the Mach, we're seeing anywhere from 6 to 9 seconds to thread a part, which is a substantial savings.
That's a crazy settings because that's like a third of the time now that you're threading.
Yes.
And we're going to dig in for the people out there. We're going to dig into this demo that you have set up here.
Yep.
You're saying that you can do this on your Swiss as well as on the standard chucker?
Yes.
Okay. So tell me a little bit more about this because you engineered this whole demo for us.
Yep.
What was the logic behind this?
I was just trying to showcase Vargas and this incredible line of threaders. The idea was to show a finer, larger thread and then be clamping on that on the sub spindle while we put in a coarser ID thread, just to kind of showcase like worst case scenario as far as like part handling. You know, you never know in a job shop, you never know what your options are going to be for doing a part complete in one operation. So this was just showcasing kind of worst case scenario.
You know, you could have picked an easier demo to set up, right?
Well, it's part of the challenge. So
it is. And for the people watching us right now, like you chose to clamp on a thread in the secondary up.
yes,
The Okuma, Genos, the L3000, beautiful machine, but you're clamping on a thread in a sub spindle and it's a standard sub spindle. It's not a main that we're starting to see, right?
Yep.
So you've got reduced torque, reduced RPM, and you're holding on a thread.
Yep.
So how did the ID thread turn out?
beautiful. I had zero issues with rigidity. I had zero issues with chip control or, you know, vibration, harmonics, anything like that. The thread's beautiful. The thread that's cut on the main and the thread that's cut on the sub have almost identical surface finish and consistency throughout. So it was zero downside to doing that.
So how does that compare? Because obviously you used threading inserts before you found Vargas. Well, how does that compare if you would have been trying to do a demo like this with the other guys?
More cycle time.
Okay. What about the finish?
I definitely wouldn't have been able to get that finish at the service footages that we were running at.
What did we get down to, by the way, on that thread on the OD?
6.4 seconds. 4 passes, 500 service footage.
4 passes.
Yes.
Where did you start with all of this, though? Did you start at 4?
No, we started at about 7.
Okay.
To be a little conservative.
Okay.
400 service footage, and then working with Josh, we bumped it up, and now we're at 500 service footage and 4 passes.
That is absolutely wild.
Yes.
And now you're going to be able to take that savings and apply it to other jobs in the shop.
Yep.
Anything that falls in that same material group or that same size range, you're going to know right away. Oh, yeah, no, we can go to 4 passes, 550 SFM, no problem.
Yep. Yep. And then it also just having that knowledge, you're going to be able to quote differently too, and be able to know that, you know, my part isn't, you know, a minute now in threading because I have 2 threads on a part. Now it's more like, you know, worst case scenario about 20 seconds. So.
And that's for 2 threads.
Yes.
I'm laughing because I've been the machinist on the floor, and I used to easily quote a minute or 2 minutes per threaded component.
Yep.
Because I wanted to leave fluff room just in case.
Yep.
I had issues with surface finish or feed rate or tool life.
Yep.
We haven't talked about tool life yet. How's tool life been on this insert?
It's been great. So I have a product or another part running in the shop right now. We were able to cut the cycle time by 19 seconds and match the old threader's tool life.
How much of the cycle was actually left? 19 seconds sounds like a really big
So
reduction.
we started at 78 seconds. We're down to
Okay.
59 seconds. So it was a 31% increase
Wow.
in production from
Yeah.
just changing a threader.
And no increase in tool cost.
No.
So why wouldn't you go over to the Mach TT then?
Yeah, absolutely. So it's it was a part that I couldn't touch any other parameters, or I was going to have inconsistency with chip control or tool life, stuff like that. So I knew that I had to leave that alone just to be able to handle every variation of that, material spec. So the threader was the only thing left to attack, and yeah, it brought us a 31% increase in production. So it's been wonderful.
Okay, so you talked a little bit earlier about how you found Vargas and the Mach TT inserts. To the people out there watching, if they haven't tried the Vargas Mach TT right now, what would you say to them?
You need to either reach out to them directly or get with a local distributor and just really rely on tooling guys. I personally believe you're only as good as the guys that support you, and having a big team of tooling guys that when your back's against the wall and you're just out of ideas, you're beating your head against the wall and just you're out of ideas, those guys are always just a fresh set of eyes, and they always have ideas or other experience that you may or may not have, and bring a solution that will work for you, and hopefully you get the same type of success that my group of vendors has brought to me. So,
Well, thank you so much.
thank you.